continuing our series of building JavaScript method from scratch for beginners from JavaScript programming basics. In this video we will be making these two methods as a function. And to make these methods we are allowed to use method that we have already built, so let's start. First is array.pop method. The pop method of array instances removes the last element from an array and returns that element. This method changes the length of the array. By examining the example input, output, and the method's definition, to build this method as a function we have to somehow extract array's last element and return it. And removing the last element means after the pop method is executed, array will be missing its last position element. So these are the two things we are focusing on. First, extracting last element. Extracting element from array requires element's position index. Now let's take simplest case possible, array with only one element. We extract last element of that kind of array by taking index as 0. And for array containing two elements, we can extract last element by taking index as 1 and, for three elements containing array, the index would be 2. Now, can you see the pattern here? To extract the last element of the array, we need an index which is length of an array minus 1. Now the second constraint. For second constraint, which is to remove the last element of an array and adjusting the length of an array. Well, listen me out for this one. What if I say adjusting length of an array, which is decreasing the length of a JavaScript array by 1 can automatically remove the last element? Let me explain. When you decrease the length of a JavaScript array by 1, it effectively removes the last element from the array. This is because the length property of an array in JavaScript is not just a property that you can read, but also a property you can write to. By setting a new length for the array, you can effectively truncate the array, removing elements that are beyond the new length. When you change the length of the array, JavaScript automatically removes any elements that are beyond the new length. So, if the original array was 1, 2, 3, and you set array.length equals 2, the array becomes 1, 2. The element 3 is no longer part of the array. So now all the missing pieces are here. Let's make a rough draft of our algorithm, which is called pseudocode. First, initialize a function. Let's name it custom_pop. It accepts one argument, an array. Second, extract last element of an array by assigning it to a variable, last element, a reasonable name. Then decrease the length property of that array by 1. And finally, return variable, last element. All done, but one case that we have not taken care of is when given array is empty, meaning array's length is 0. In that case we have to return undefined. Modifying the algorithm. After initializing the function, check if array's length is 0. If yes, then return undefined. Here a flowchart representation of our algorithm. Now let's code it up with JavaScript. Initialize a function named custom_pop with parameter arr. Check if array's length is 0. If yes, then return undefined. Assign last element of an array to variable last element, minus the length property of that array by 1. Return variable last element. Next one on the line is array.add method. The add method of array instances takes an integer value and returns the item at that index, allowing for positive and negative integers. Negative integers count back from the last item in the array. Well, if given index is in positive integer and is within the bound of an array, then it's easy, just access the element and return. Problem arises when given index is not an integer, and if it is not positive integer. Remember, we can only access element in array with positive integer value. And another constraint is that index have to be within the bound of an array. So let's tackle these constraints one by one. First, check if given index is an integer, otherwise return undefined. We can check if given index is an integer by using number.isInteger method, which is a static method determines whether the passed value is an integer. Secondly, for negative index passed down to a function, we have to convert it into its positive equivalent index. So how would we do it? Again, let's start by taking simplest case possible, array with only one element. In this array, we can only access one element, the 0 index element, which corresponding negative index is -1. And how we convert -1 to 0? Simple, by adding 1. And in array with two elements, 0 index corresponding negative index is -2. Can you see the pattern here? As length of an array increase, 0 index corresponding negative index decreases. So, to get positive index of an element from negative index, just add it with length of an array. And it works for all valid positive index. You can try it out by yourself. Now, for another constraint, we have to check if index is within the bound of an array. For this, index should not be less than 0, or greater than or equal to length of an array. And importantly, we have to convert negative index into positive before this step, as it is easier to check this condition with positive index. And if index is not within the bound, we will return undefined. Now let's write our algorithm of custom add function in simple English sentences. First, we initialize a function with two parameters, array and index. Let's name it custom add. And this time let's start with checking if given array is of type array, as I have shown you how to do it quite a few times in this series. And if given array is not of type array, then throw an appropriate error. Secondly, check if given index is an integer. If not, then return undefined. Next, check if given index is negative. If yes, then add array's length to it. Next, check if index is within the bound of array. If not, then return undefined. And finally, return required element corresponding array's index. Here a flowchart representation of our algorithm. Now let's code it up with JavaScript. Initialize function named custom add, with parameters, array and index. Check if array is of type array. If not, then throw an appropriate error. Check if given index is an integer. If not, then return undefined. Check if given index is negative. If yes, then add array's length to it. Check if index is within the bound of array. If not, then return undefined. Return required element corresponding array's index.